Okay, we got factoring. Okay, so this is a trinomial. And one way to tell if something is a binomial, trinomial, is just the number of terms. So I'm just going to quickly point out that there are 3 terms in here. So this means we have a trinomial. That's the concept of it. The polynomial means just as many different ways we can represent it. There are quite a few different ways of factoring. This happens to be a scenario, and we're going to relate this to the standard form actually. So I'm going to make sure I write that in there because that'll be helpful for us to realize that this is in standard form of a quadratic. This trinomial, oh, not again. There we go. This trinomial, can I undo that? There we go. Let's fix it. And RD, there we go. Sorry about that. This trinomial is happens to be quadratic, and most of the time they're written in this form: ax squared plus b at x plus c. We'll quickly put in the colors here. Just helps for referencing when we color code things a little bit. Plus c. This happens to be our c value, negative 36. Positive 5 happens to be our b value, and in this case they don't put a value in there. There we go. This is a 1, but that's our a value in this case. Okay. When something has an a value of 1, we can technically look for 2 numbers. We need 2 numbers that multiply to whatever the c value is. And in this case, that happens to be negative 36. Now, we also need to find 2 factors that add up to whatever the b value is in that standard form. Now, the reason I only put the c value when a is 1 is because technically it's a times c, and anytime it's not 1, you'd have to multiply the 2 values together and we'd have to find a factor of whatever that is. Well, because a is 1 times c will always just be the number c. So a lot of times they say, hey, it's just the letter c. But to have a better understanding of the true nature of this, always realize you're looking for 2 numbers that multiply to whatever a times c is. In this case, a is 1, so it's just the value of c. So we're looking for factors of negative 36 and that are going to add up to positive 5 also. Okay. We can kind of list them if we want really quickly. You might actually know a few off the top of your head that might help, but 36 has quite a few factors. We'll write them side by side here. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 does not, and 6 goes in. So these are all of your factors, and they're not in any type of real order here. But remember, I did pair them, and they have to be in pairs, so think of them as sets, and we have to use the set together. Okay? Because this is a negative value, what that means is one of these is going to be negative. In other words, you're probably going to look for a quick way for mentally math doing this is to look for difference of a pair that's going to equal positive 5. So we quickly go through this. Obviously, the difference here is 35. Difference here is 16. Difference here is 9. Difference here is 5. This is most likely our candidate. So let's go ahead and put these in. 4 times 9 and 4 plus 9. Okay. If the 9 is negative, that checks out here. But if the 9 is negative down here, then we'd end up with negative 5. So that wouldn't check out. If the 4 is negative, that does check out again. And if the 4 is negative here, that checks out down here. And negative 4 plus 9 is our value. Now, technically, we're going to go through like decomposition and common factoring and factoring by grouping. But again, because the a value is 1 here, we can really quickly get into our factored form. And I'm going to write out factored form just so we know that's one of the goals here when they say factoring. The factored form of this quadratic is going to look like this. Y is equal to ax minus r, x minus s. I'm going to write those in after. It's faster to just change the color. And in this case, the r and the s are the roots, or x-intercepts. Okay, so since those are the x-intercepts, and we have our pair here of 4 and 9, or I should say, sorry, negative 4 and positive 9, we're going to write this in our factored form. Y is equal to, let's say we don't know what a is yet, x subtract negative 4, and x subtract positive 9, so we just write in 9. Now the a values, let's say it's unknown in this case. We're not sure what it is quite yet. We can, though, reference the very first one here. A value is 1 there, so the a value is 1 also here. X subtract -4 is the same as writing x plus 4. And once you get the hang of that, you can kind of skip that step. You'll just right away know, okay, I'm just going to put the opposite sign. Because this was positive 9, this became negative 9. And 1 times anything is just itself. So I went into a lot of detail there, but you really don't have to go into that kind of detail. We've got x minus 9. So this is our factored form of that. What we should do to double check, we have reference, or we have access to a graphing calculator that's pretty helpful. So let's go positive 5 and negative 36. Y is equal to 1x to the power of 2 plus 5x minus 36. Zoom out a bit. And if we take a look here, we've got a vertex, we have a y-intercept. Okay, what I'm going to do is I'm just going to draw attention to a couple things, and then we'll put the factor form over it. One of the things we want to draw out is this is our y-intercept. Very quickly, so I'll label it y-intercept. So you'll notice this is the y-intercept, and what's important about that is in our standard form, negative 36, it's literally telling us our y-intercept is going to be at negative 36, the y value, and the x value happens to be 0. We also have two x-intercepts. One is at 9 and 0, or I should say, sorry, negative 9 and, oh, I didn't put the bracket there. Negative 9 and 0. We'll label that x-intercept. And the other x-intercept is at 4 and 0. 0. I'll label this one too as x-intercept. Okay. So we have our two x-intercepts, we have a y-intercept. We haven't really got to vertex yet, and that one's a little more complicated to work out in this specific question. But our factor form, if you remember, was y is equal to, we don't have to write the 1 in, so we'll just write in x plus 4 and x minus 9. Oh, did I write those backwards? I may have written them backwards, which doesn't, hold on. Oh, that works out. Did I write them backwards on this page? I feel like I did. Negative 4. Huh. I have made an error somewhere here. Negative 9, that's correct. And 4. 5, positive 5, negative 36. What did I do wrong with my factoring? When you put in negative 4, it should become positive 4, which means negative 4 is one of the x-intercepts. Huh. It's a good thing we put it in this graphing program. I don't see the error, though. The error lies in this. Negative 36 is correct. Negative 4 and positive 9 are our two x-intercepts. When we put those values in, x minus 4, x plus 4. I'm confounded. I don't know what I've done wrong, but there is an error. The reason I say that here is if you look, we have a positive and we have a negative, and those are on the opposite values what I've written here. So I've made an error in the factoring part.
Don't you like flip the positive 5 to negative 5 or something? I don't know.
If it was, did I flip to negative 5? This is positive 5, right? Yeah.
Yeah, don't when you like.
Oh, did I flip it? No, I don't.
No,
think I did.
you just put.
I think it's.
Do you flip it?
No, it is the b value. You're looking for the b value here, and you're looking for a times c. A is positive, negative 36.
Don't you flip the b value when you like do that thing? Like change it to negative instead of positive, and the other way around? Because that makes sense.
You're right. It wouldn't make sense in this instance. And unless I've lost all memory of my factoring skills, I don't ever remember doing that. Give me What on earth have I done here? X minus r. That's got to be right. Negative 4. What on earth have I done wrong? Did I type? Let's put this to negative 5. Yeah, it flips it right around, which would mean my other one's correct. Oh, I'm having a major mental issue here. I don't know what I've done wrong here. Okay, give me 2 seconds here, Nathan. I'm going to call in. We're going to erase this stuff here because we realized I jumped the gun. And these aren't actually the roots yet. What these are is just the values we put in. So we still call this a, and we say x minus 4 and x plus 9. Okay. And then from that, well, let's talk about the a value. A value is 1, so we know it's not going to change anything, so we can kind of drop it off there. X minus 4, x plus 9. Now, from this style of factoring, the opposite of this is the x value. So one of the x-intercepts, we'll call it x1, is positive 4, and the other x-intercept, we'll call x2, is negative 9. And that makes way more sense when we come back over here. We have x minus 4, x plus 9. We'll change this. This was actually positive 5. And now they overlap. That's my fault. I'm not sure why I assumed they would make the x-intercepts. Does this make sense as a factoring style?